Hello everyone. The topic of my presentation today is applying the DSRM process model to NLP driven decision support system in gastrointestinal disorder management. Moving on to the second slide here. The second slide here shows us the introduction to the DSRM process model. So this framework here includes 6 stages, starting from identifying the problem, defining solution objectives, designing and developing the artifacts, demonstrating its use, evaluating the artifacts, and the last one is communicating the findings. I will walk you through each stage as applied to my research. Moving on to the next slide here, problem identification and motivation. So this is the first stage, which is identifying and motivating the research problem. As I said earlier, gastrointestinal disorders are challenging to manage only because it is hard to evaluate their symptoms and variable patient experiences. So clinicians often underutilize the unstructured clinical data, such as free text clinical notes. So these clinical notes, they hold valuable insights and symptoms and treatment responses. So the problem here lies in bridging this gap between leveraging this unstructured data and to make the enhanced decisions. So this system here is motivated by the need to enable those pattern recognition for disease management. Number 2, improving diagnostic precisions. Number 3, which is I would say the most important here, is personalizing treatment plans for patients with chronic gastrointestinal conditions. Moving on to the next step here, which is objective of the solution. This is the second stage, which actually focuses on defining solution objective. In my research, I propose that NLP-driven DSS aims to do 3 main objectives. Number 1 is extracting clinical relevant information from those unstructured notes that we talked in the last slide, which are usually the free text. We can extract those using the NLP techniques, and the techniques that we can use is named identity recognition. Number 2 objective here is to identify those symptoms. As we said, we need to identify the trend and predict the flare-ups and often those actionable insights. The number 3 is providing real-time decision support to clinicians and managing those complex gastrointestinal cases. So these objectives ensure that the solution is tailored to address both clinical and operational challenges in chronic disease management. Moving on to the next slide, and the third stage of this process is we establish the theoretical basis for this solution that we proposed. So this research, as I said, integrates NLP, which is natural processing language, techniques like tokenization, normalization, and sentiment analysis enables the system to process and extract actionable insights from unstructured clinical notes. By unstructured here, I mean free texts. Number 2 is clinical decision support system, DSS. So by building on the decision-making framework, the system support personalized and data-driven its clinical interventions. Number 3 here is domain-specific NLP model. So in my research, I talked about these 2 tools, Clinical BERT and BioBERT, so which is pronounced as BIOBERT, and it enhances the accuracy of medical text analysis, ensuring relevance in the clinical settings. So these theoretical foundations strengthened the artifacts' capabilities to address the real-world clinical needs. Now, moving on to our fourth stage, which is artifact design and demonstration. So in this stage, the proposed artifact is an NLP-driven decision support system. the designing components that we are going to look at is the data source, first of all. So the data source, as we know, are the clinical notes. We can also look at the patient demographic and their treatment records. Number two is the NLP model, which is the NER, as we already mentioned in the last few slides. We will use NER for symptom extraction, temporal analysis for tracking symptom progressions, and pattern recognition for identifying any potential flare-ups. The number three here is the decision support layer. So this component here provides risk score, flare-up alerts, and any recommended treatments. So these components here, they make a demonstration plan. So a pilot study which analyzes historical patient data, and for instance we can look at the system that processes the patient clinical notes and extracts symptoms like abdominal pain, identifying increasing trends, and flag any potential disease flare-ups. So that's what this flow chart here shows, the things that I just said. So the data source is the clinical notes, and then we are going to look at the pre-processing model, and then we can also look at the NLP model, moving on to the temporal analysis module. Then we're going to look at any patterns. We will try to predict the flare-ups and just detect any trend that we have. Then we move on to the next stage, which is the decision support layer, where we will look at the symptoms, any risk scores, any alerts, and the final output can be like a report or a dashboard which can just show us, what are our findings. The next step we have is artifact evaluation. So here we are gonna look at the evaluation, which is very critical to validate our artifacts performances. So we're going to start by looking at metrics for evaluation. We will look at three major metrics. One is the accuracy, efficiency, and usability. And then we're going to look at the evaluation method, which is we can conduct experiment using the de-identification clinical notes to test the ability of our system. And we can also test their ability to extract and analyze system. Then the second method we can use is comparing system prediction with actual clinical outcomes such as flare-up occurrences. Moving on to our last stage, which is the conclusion. So to conclude, the DSRM framework has guided the structured development of NLP-driven DSS for gastrointestinal disorder management. That's how we started. So this system, we can conclude and say, has the potential to extract those actionable insights from the unstructured data, and also it can improve clinical decision making through predictive analysis, and lastly it can enable personalized treatments planned for those patients. I would say for the future work, it includes refining the artifact with the real world data, further evaluation and scaling the system for broader use. And yes, I would say thank you for listening, and I welcome any questions or feedback.